Ma'am, I think we can start.
Okay, yes. For me, it's okay.
Okay. Good morning, everyone, and welcome back to the fourth day of our FDP, that is Research Opportunities in Robotics and Automation. Today we have Dr. Ekta Singla, who is a serving associate professor and head of Department of Mechanical Engineering at IIT Ropa. With her research interest in modular robotics, service robotics, customized optimal design, evolutionary robotics, and hybrid morphologies, she has more than 15 years of experience in robotics and in applied optimization fields. She is a recipient of Institute Gold during a master's program, National Doctoral Fellowship during a doctoral program at IIT Kanpur, CNRC Postdoctoral Fellowship for UPMC Paris, and a recent national award from Institute of Engineers. Her current research projects are in maintenance and service robotics, in rehabilitation robotics, and progressively through industrial partnership with two UK-India collaborations, an active association with University of Stony Brook, New York, for robotic application in medical and defense field. To enhance the training and learning environment of industrial robotic field, she has got IIT Ropar to sign an MOU with Tata Automation for establishing a robotics research center and a training center at IIT Ropar. Her contributions are visible through four completed projects, various journal articles, editorial in reputed journals, and contributions for various societies. At IIT Ropar, she has actively taken up administrative responsibilities at various levels relating to student affairs, academic affairs, and has also chaired a lot of events organized by IIT Ropar. Dr. Ekta found an interdisciplinary group called Punch Robotics to focus on academic, professional, and innovation related activities, which is not only limited to IIT Ropar, but can also be connected to many, is also connected to many institutes in the regional area. So, with this introduction, I would like to hand over the dais to Dr. Ekta Singla. Ma'am.
Yes. Thank you very much. Dr. Sudha was there because I couldn't see who was speaking.
I
And
am Ashwin Nayak, ma'am. I'm Professor
okay,
Ashwin
hello.
Nayak.
Yes, thank you, Dr. Ashwin, and for the introduction. And I hope that whatever is being said, partial of that I'll be able to convey here as part of my duty, particularly because your topic of the entire 5 week program, 5 days program is related to the robotics research. And if it is to be connected to Industry 4, so I thought of presenting this part of my work. So thank you. And here we go. May I know in the beginning, because I was told some specific hours like 2, but
Yes,
it will be better to what is the time I have so that
uh,
I can go slow and fast accordingly.
ma'am, we have time up till 12. That's 2 hours from now.
Right. So we'll have a break in between, and I could see it's kind of could around 7 past 10. So we can I will be moving by taking a few things along. For example, a few introductions and very little bit about my other research. I would not like to go for more in that, and then we'll move to the importance of modular robotics for Industry 4. So here we
Okay.
go, and just to introduce, yeah, we'll have a break also in between, kind of 5 minutes at 10, 11. So this is just for the audience to plan accordingly. Yeah.
Okay.
So Right. So I am from IIT Ropar as mentioned, and the location because we all are from different locations. So I thought of at least presenting, although you know Punjab very well. And this is all the new infrastructure from IIT Ropar because this is mechanical engineering department. We call it as the building Satish Dhawan block. By the scientist's name itself, all the blocks and all the buildings are being named. So whenever you get a chance, please, it's a beautiful campus now, and you may please visit. This is just a glimpse of my lab where we are working particularly to related to modular robotics because either I work in different directions, but even if it is serial manipulator, some part of the hybrid structures may be the combination of serial and parallel manipulators, and may it be in the direction of exoskeletons. I try to see how the modularity can be a part of that particular research. So here this is something which already being mentioned by Ashwin that we I also tried because training in robotics, for example, this Atal course and many such courses, I always admire such platforms because in the last, in particularly in Indian robotics, we all of us need to contribute, may it be in teaching or learning ourselves. And in that direction, I felt that a better learning can always be if we make it in association with our industry. So this was just a move a couple of years back, and at that time I thought that our whatever facilities we have in our department, particularly I thought of taking it from the Indian companies. Earlier I had one or two KUKA robots, and then I thought of taking these. Uh, Now it is not called as Tal Bravo. Now it is BRAL, like Bravo Robotics Automation Limited. So the name of that small firm being started by Tata is being changed, but you will notice that the importance and the utilization of Bravo robots in India is increasing. So I would say like it is a contribution from each of us that we should encourage and give opportunity to the Indian companies who are coming forward for the manufacturing part of robots, and that will help us because in case you are good in research, you're the firms are Indian, and they can always we can always, because if we are ready for our research for them, then better collaborations can be done because their manufacturing units are here. But if we are importing the robots, then sometimes you cannot give them directly your research work. So this is how I would like to present. And just very small digest of my other research directions, because in total you will find that I work with customized robots, may it be like you call it as something where you need to go for unconventional parameters, because if we are talking about customized right here, then you need to have some extra unconventional parameters, may it be redundancy, right, or specific designs which play a role. And whenever the customization comes into picture, I'll detail it later because today our discussion is on modular. Then this modularity is a part of it, right? So just one second. Just this will be a part of it, and this is what we'll be discussing for today's topic, and that is related to the non-repetitive tasks. Because till now, I'll just introduce that normally the robotics parameters for the last robotic manipulators for the last 30 to 40 years, I would say more than 4 decades or 5 decades, if we are not taking only Indian robotics in account, then for it had been started mainly from repetitive tasks, right? One of the reason. But now for customization, for non-repetitive, for flexibility to be incorporated, and which is a part, which is something which is related to industry 4, there the importance of modularity is there. This is what we'll be discussing in details. And I also work with hybrid manipulators, and intelligence have just started working that whatever we are doing, then the importance of artificial intelligence can that be incorporated in all these projects. So this is some research direction, and just one or two videos. Just recently we are working on exoskeletons. So I would like to say that here also I work with the same keywords, that how to look forward for customized manipulators, and where the importance of mimicking the human motion and working on the manipulators or the devices which are modular in nature. Only then, this customization that can be their cost and the manufacturing aspects can be optimized. So this is just one or two, this is all for introducing my work and my lab, right? That what type of work we keep doing. And to introduce today's topic in a better way, before going into the introduction part of it, I'll just show you a glimpse of very recent work, which because this is being taken up by my student, PhD student. My first student is already passed like 3 years back, and he started with modular robotics, and now he is University of Leeds, and after his two postdocs already settled. But this is then it was taken up by Anubhav. In between, another PhD students are working because presently I have 6 or 7. But this was started with my first PhD student and now being taken up by Anubhav is almost closing it. And when we see, just I'll show the complete video in the last because we'll be talking about it first. But this is all that in serial manipulators. So this is not related to hybrid yet, but how we can actually work with. So I'll just show you some glimpse that where we'll reach today. So in the beginning, yeah, here. For example, if there are some unconventional parameters, then how exactly, we can always look for some specific customized robots and can we make them with. So this thank you is actually after the for this entire video, but we'll come to that. This was just to show you the glimpse of that particular video, which you can understand and admire in the last. So to begin with that, let us talk about where the robotics started from, and you know that in all our very established books and the definitions, there we talk about the repetitive task being one of the basic feature where the robotic tasks in manufacturing had been started. So even if you can say particularly the partial part of the industry 3, right, where it's not that industry 1 or 2 didn't have the automation, but in particularly industry 3.0 was related to your robotics research, that is your robotic manipulators which came into manufacturing. And particularly the reason was that if we have some very difficult to do tasks, if there are dull repeatedly doing tasks, something which is extremely dirty, unhygienic, right, or dangerous, for all those things, uh, you just to say that okay, men, if you just take a manual man force there, then for such repeated tasks it was not so um, recommended. And there the importance of robotic manipulators, which all of us know about as industrial robots, being it be welding or repeated pick and place. So everything is now, this is a textbook stuff and a kind of 4 to 5 decades back, even more for outside. But for India, I would say yes, in automotive, particularly in the automotive sector, it had been started long back, right, and where we had imported enough of robots. But I must say that even 7 or 8 years back, when I had a very good gathering on the beginning of my punch robotics of this there's a platform, I'll talk about it. So there in a presentation or in totality, if you talk about Indian robotics at the global map, so now it is increasing, but at the global map, Indian robotics is, the number is such, relative number is such that small that many people call it zero. So I know that starting from like IIT Delhi, Madras, and ISC Kanpur particularly. So and then Guwahati, we have very good. I mean, many labs. They were working. I am talking about a decade back, but still it was considered a zero because the number was such a small. And then I would say there's a yes, I can use the word exponential change, and many people, many labs may it be in the form of startups or big projects or small projects or industry, they have come forward now. I'll be talking about Indian robotics also for a few minutes just in some time. And before that, just to introduce more about the robotic manipulators, because we are today talking about the serial manipulators only, for which during this entire course you might have learned about its kinematics and dynamics. But why it was important? Because you will see that many manufacturing areas which which need robotic assistance is having some different reasons. So automotive sector had been started, as I said, long back, and then came like electronics fabrication, where the precision was required to micro and nano level, right? These are not the only reasons that precision is only the reason, or you have to work only for accuracy. I mean, I'm just moving from the non-repetitive dull tasks to other reasons where which make the efficacy of robots better. So here you will say that chemical industry, rubber, plastic, these are all being, even if the firms are very small, in fact, these days small scale and middle scale industries, they're also looking for robotics, not only to have, just for the same reason of that we need automation or only for precision, but environmental issues, dangerous issues, for example glass work, right? And then ceramic, these days they are not being used only for dangerous, there are other reasons, and that is equivalent to the way I'm talking about for wood and furniture. Unconventional designs. This is another important aspect related to wood industry, furniture, glass, ceramics. So there you will find that you can go for unconventional processings using robotic arms, and that is being the latest. So in a better way, I'll show. I mean, apart from hygienic and germ free, for example, in food, yeah, small firms, they look, everybody would like that rather than going for manpower, it is better that the man skills can be used, right? It's to utilize robotics. So wherever actual food work is being going on, that better be done in a very hygienic way. So, and the importance of robots you have seen in the very recent, in our present pandemic, it's huge. So, what applications robots are in use today? So today, whatever I talked about, if I show you through scenes, and then we'll see what is the common behind them. Apart from industry, warehouse, I'm sure you know about high-tech technologies, the entire Amazon, how it is being used. High-tech is serving them. High-tech is an Indian firm, right? And they are mainly known for their unmanned vehicles, and particularly, I mean, all these how they are serving to the e-commerce, right? And that is all through their through all these mobile manipulators. So that is why I'm saying that we should know and we should encourage Indian robotics. And apart from warehouse, where you can say not only the manipulator, like the mobile robots, but mobile manipulators are being used. So you can, I'll show you the glimpse of it. But other areas, assistive devices, may it be in building. In building works, it's getting normal at places. Now, it is not yet so normal in India, but you will find it very soon. And medical, you know that it is being imported, but yes, the utilization of robotic arms in medical has been seen by all of us. And then comes your defense, service, and agriculture. So I have not shown my work in the last 2 years. I'm working in agriculture also, particularly in the area of vertical farming. And there also the idea is to use again some modular robots where according to the different requirements of agriculture work in vertical farms, the location, the space is less, environment is constrained, so you need again customized robot, and with the same idea, with the same background requirement, knowledge, it's just the application which gets changed. So your all learning have a sense, right? And similarly defense. So here in the defense, I'm showing you a picture which is actually a picture of the mobile manipulator, because you'll say that you have to work on the mobile part separately, and you should know how the manipulator which is being attached to it will be controlled, right? So this total, so in total, out of all these, why I am showing it here, right? Because we are moving towards customized robots. We are moving towards the importance of different configurations. But for whom? different configurations for robotic manipulators. You will see what is the common behind this complete variation in application. So on this variation, one of the things which is common is the structure which is being used, the mechanism which is being used for robotic manipulator, right? And that is the serial arm. So here with different requirements, whatever we need, sometimes it is small in size, larger in size. So your understanding on kinematics, dynamics, that helps us to design it according to the requirement, according to the task. And that is what I called as task-based customized manipulators. Because yes, the same robot will never be used everywhere. You have to customize it. At the moment we are talking about customization, then the other thing comes into picture is the cost. So for both of them, the answer lies somewhere in the modularity. And that is how I would like to just introduce the reconfiguration, the concept of it, and the significance. Because now I introduce with this introduction on the repeatability, I'll say that what is the meaning of non-repetitive task and what is the importance of reconfigurability. That is what we'll be looking at. And well, this is just the definition which we had just covered. And I would like to start from the concept and significance of the reconfigurable manipulators. So here the idea is that whenever we are talking about a robotic manipulator, as I said, what is common in all these applications is the structure. And you have already seen that your understanding on transformations, frame fixations, forward kinematics, inverse kinematics, right? From all these things, you have found that we can always have these multi-body systems designed through a very systematic way. First, you will see what is required. Okay, maybe you give some 3 or 4 points. You'll say that I need some robot which should have, say, may not, you don't know task, but maybe you know the DH parameters or specific parameters. Some people go for only Euler parameters, right? Rodrigues parameters, or whichever parameters you use to define your frames, right? And normally used are DH parameters. I'm sure that all of you have already studied it. You have hands-on on that. So what it does, DH parameter, it's a convention given by Denovet and Hartenberg, and that convention is just to introduce or just to define our frames which are helping us to define one rigid body with respect to another. So I'm speaking from the mechanical engineering perspective. And then even if there are different connectivities, it's not normally you will find, I'll just come to it. Normally you will find that in your DH parameters table, I'll show a few tables later. In that, your alpha, which you call as twist angle, that is normally either 0 or 90. You will notice that, right? Why? Because that angle is actually between the angle between Z2 and Z3. I mean Zi and Zi plus 1. Consecutive joint axis, right? So if it is an angle which shows us the angle between consecutive joint axes in the direction of the x, that is the x direction of the previous. So if we are talking about two frames, then between the frame I and I plus 1, right, alpha I, or that twist angle, is related to the angle from I, Zi to Zi plus 1 in the about the direction xi. So you know all these definitions. So all these definitions are once we know the robot. We give you a robotic arm and we tell you that, okay, please, associate or mark the DH parameters, right? Normally you do the forward kinematics like that. You say that, okay, if sometimes 3 degrees of freedom given to us, sometimes a manipulator of planar manipulator is given to us, or we are talking about even redundant. I have worked with maybe 12 or 8 degrees of freedom in series, right? You can work with 30 and you can define the DH parameters for that. You will have a 30 row table ready for the DH parameters for that robotic arm, right? So what is difference? Basically, what is being done is that every link which we are considering, if we are considering that as rigid body, is associated to the next link using a set of 4 DH parameters. And what it is doing is, given you being given as a particular robotic configuration, if the configuration is given to you, you will always be able to mark it, but you'll say that all the conventions will be marked first, and then you will write the table, and then you'll write the forward kinematics, and this is how. But what if I give you the table and I give you that, no, 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 I want table like this, I want the alpha to be 90, I want this particular d to be this value or that value, and then you construct the robot for me. And then you may say that, okay, I can make the simulation, but I don't want how to construct it. So this is where the importance of configurations or the modules come, that can we have the modules ready so that we should be able to just construct whatever we need. And there comes the importance of unconventional, the importance of modularity. But apart from that, I have also worked with, if these connectivities between the Z or the twist angle is not 0 and 90, and that is what I call as unconventional. I'll come back to this particular point. This was just the introduction, that we'll be talking about how to get unconventional modules to get any manipulator which we want, right? So, but to move toward that, this particular part before our mid time today, I would like to introduce many of the other modular robotic manipulators which are being given by different industries, different other groups. So here you will find that robotic arms or robotic manipulators are not only related to just the serial industry. In fact, mainly they are not related to industry robots. You'll find that from 90s, may not be in India, but people have worked with these small modules which can be connected. For example, two of the options are being shown, known as polybot, and there every module is 1 degree of freedom, and many of the connectors are passive, right? So they give us a modular library in which you have active components and passive components. And from 90s, this particular concept of modularity being there, but normally people from electronics background, they were using, and there was hardly, the sizes of these polybots are very small, and so there was hardly much role of mechanisms, or as you said, the heavy duty robots were not involved. So similarly, mtran, so these are just some of the options how people have tried their hands and get into the research of modular robots, because this is the Atal course in which it is being mentioned for robotics research. That is why I'm showing this factor. Sometimes just for the introduction of modules and my work, I skip it. But for this group, I am showing it and showing you some of the concepts, because then only, even if you are a person from mechanical engineering, you are a person from electronics background, or computer sciences, and even materials, yeah, biosciences. So basically, you can connect yourself, depends upon your background information, that how you can contribute even in this area, or you can work in this area if you like it. So reconfiguration, these all are reconfigurable. Another aspect is, there is a difference between reconfigurable, that means you can reconfigure the same the configuration being given. The example I can take, that if I have 4 degrees of freedom or 5, for manipulators, I can have Nascara to begin with. Like, we had studied long back the textbook stuff, that we had a configuration Scara, we had a configuration Puma. All these are having basically revolute joints, right? Scara had the final joint as prismatic, but all these are having specific configurations, that okay, first Z and the second Z will be connected through 0 or 90, and there is a offset between these two specific offset is between any two x's, right? So these things are being done, being shown, but configurations are fixed. But if you want that the same robot can be reconfigured, that is what being called as reconfigurability. So can it be reconfigured itself? That is called self reconfigurability. So these are few terms I thought of presenting to you. Then come if the modules are homogeneous or heterogeneous, because it's not that the all modules you say, for example, in the right side in Amtran, this work is homogeneous. It's very clear that almost all the modules are similar in structure, and the presentation and the working or the connectivity is such that they can be connected together, and then you can make different formats. So many people are working with, very small sized reconfigurable robots. They can become legs, or they can connect together to become a serial arm, as right in serial like a snake. So these things are in, but this is a separate direction in which you are normally working with the planar or spatial, but the robotic modules are very small. So rather than their inertial forces management or kinematics, etc., you are working with the electronics part of it because you want to make them intelligent. And heterogeneous is normally when you have a library of modules where the all the components of that modules are, they are not really same, right? They are not really same because of the different reasons. So for example, here in the left side or the right is again homogeneous, but you can have some of these structures in the left. For example, at the toms you have the again another conceptual design of the modular robots in which many of the components, they are not similar. So that is called as heterogeneous structure, that the complete library is heterogeneous. So another aspect is if the assembly is fast or slow. Particularly this aspect is related to the self reconfigurability, and if it is self repairable, because if we say that one of the small modules, say in Sambot, the modules are very small, and you will find that this is actually, these are equivalent to our electronics parts, and only that much is required, and they can turn themselves and then connect at any orientation. So if it has six faces, so at any face it will connect to each other and form a new shape and what we call as a new configuration. And then which part can be helpful in moving, which part can be helpful in, even for stairs, if you want stair climbing, such modules people have worked on. It's not that they are ready, but as I'm talking to you, this is another research direction. Particularly people into electronics, they prefer this. And the controller, and more importantly the importance of the uh, algorithms being used for the understanding that what is the configuration presently it has, and then it should have the controller accordingly. So these kind of background work is required just to introduce to you the research robots in that. Yeah, multiple modules can be attached. So these are a few of the aspects in this concept of modular robots. And some of the other aspects, as I said, is last I have added in the last is the degrees of freedom. So if each joint, for example, this superboard, till now we were talking about that each degree is 1 degree of freedom. Each joint is 1 degree of freedom. Normally in our serial manipulators also, we assume that we'll take every joint as 1 degree of freedom. And here, but here you'll see that this superboard, this concept here, each joint or each particular module which they have made, that itself has 3 degrees of freedom. So this is another, but increasing the degrees doesn't mean always good. So my point is, if required, this is another example. Okay, so what is the importance of robotic arms, right? Why that was required, and the introduction to my work, towards my work. And because, as I said, this was all to show you that it's not a very recent concept, even from 90s. So this is also coming from 2 decades, right? And more than 2 decades. But what is recent is from the last 1 or 2 decades, particularly in the heavy duty robotics. As I said, all these were small in size, and the importance of, because the moment you have heavy duty and one, you can say, okay, there is a large link which is carried by another link. You have to think about the all the inertial forces. In fact, when we are talking about dynamics, now you might have already studied in one of the in any of your, I don't know the time, the way you had already taken the lectures, but this is the fourth day you might have got introduced to dynamics. There a small change here or there in your masses that completely change the dynamics, and then how can we talk about configuration, and then who will control it, who will write the dynamics, who will write the new kinematic model of it, right? This everything needs to be written again, and that too automatically. Only then it is reconfigured, right? It's not that okay, you can just put the components differently and in a different pattern or different order, but you have to take care of all these modeling, may it be kinematics, may it be the dynamics of the system. So to talk about this, I just show you first, as I said, the importance, the requirement of it, why we should go into such a problematic thing, in which you have to look for customized ways. You are changing it, and then you need an automatic way to give the new model, kinematic or dynamic, to the new configuration, right? Why that is important. So first, let us see that why. So here the idea is that we are looking for the design of a manipulator, right, for a specific requirement. Now I'm connecting to whatever we have discussed. Till now, the takeaways were two phases I showed you. One is in which we had seen during the introduction, we had talked about the importance of robotic manipulators in almost all the fields, right? And it's increasing. So this is not, these are not just industrial arms. So when you are working with serial manipulators, doesn't mean that you are working for the industrial arms, which are 4 decades, old. No, they are being increased, their applications being increased, and the concept and the feature which is being added is the feature of customization. So when we are talking about customization, then the importance comes that okay, the environment is being changed. You cannot have a KUKA robot being bought, or even from Bravo being bought, and okay, start using in the agriculture area. You can always use that in the fields. Okay, there are large fields and a big KUKA is being used for maybe for weaving or whatever is being required. But particularly if you are working for a customized, as I said, I would like to work for the vertical farms. Now, vertical farms, can you take a very heavy or small robot that is KUKA being lifted and then being used? Maybe yes. But then can we go for only the required small sized robotic arms being used as according to the task? So this is what is the base. This is what is the base of the customized robots, where the issues come about the complicated tasks, right? The environment, the complete working environment is changed, and you may not need the robot every day. You may like that, okay, I need it for this particular season, and then it is useless for me. So your constraints are being changed, your environment gets changed, your job gets changed. So this is all the aspects of customization in general, and here for the customized robots. So for example, it is being shown that if given this environment, can we say that we are looking for a robotic arm? Can you design one for me? Which can reach to these? TSL is the task-based location for me. TSL being 1, 2, which are being marked here, TSL 3 and 4. They are actually for the task locations that you say, I need a robot which should be able to work here, there, third location, fourth, or maybe a set of large number of locations. So you will say that I'm interested in working in that. So how will you get the entire structure ready? And even if you are talking about only the simulations being ready, you give me a design, and the design means what? You will give me a DH parameters, which will be able to reach here. Or you'll give me the inertial forces or the torques which are required to do that task, right? But then design is one part, but getting it manufactured is different. So this is another example of the same design for the cluttered environments, and you will find that realistic environments here at the left side, I'm showing you just because this was all from the lab work itself. So taking the structure of the lab or the environment of the lab itself, as one portion of the lab as the example, right? If we say we have modeled this, in fact, these days, one of my work is related to the modeling part of it, where we are not using. I am just connecting this work with people who are working in computer sciences and algorithms, because how to convert the uh, videos or the pictures taken from the camera, may it be picture form or any frames, right? Then to the model as required for these 3D models directly. That is, I'm not talking about from the scanning to the model. I'm talking about from the frames, the 2D frames to the modeling, 3D modeling. So these algorithms are there with the computer science guys, or even my student who is not from computer science. He had learned those and worked very well and associated this to robotic. Our raw system, and that work I'm not presenting, but I'm saying that how your learning can be utilized in this area. So here, for example, this model we prepared long back, kind of a decade back, but now such models we are making not by simply going to the calculating the dimensions or actually looking at what dimensions and then going for the assumptions, because it's not that the actual area was not like that. So that particular part can be skipped by just converting from by utilizing the advanced technology to convert in seconds or maybe in minutes or maybe half a day, depends upon the complexity of the environment. You can just take a set of pictures, right, and then from that the model of the environment can be developed. So I just connected it to that recent development into that. But any realistic environment, may it be from as I said, this is just an example from the lab, but may it be from any calamity which has happened, or may it be from as we were talking about any agriculture direction. Okay, so you can just take the environment into picture and then say, okay, we are looking for some points, for example, just exemplary points. These exemplary points doesn't mean that this is the path which is being required. But first, to design, you would like to know that I want the robot to work here, left side, here and here, so that the size of the robot, the dimensions, its carrying capacity, everything, and its reaching capacity, right, that can be designed accordingly. So this is called as task-based designs. And the importance is that we need to design them for highly constrained environments, and we may need different degrees of freedom. That is also a part of the design. May it be very large, normally they are large because if it is constrained, but if the constraints are less, then the degrees of freedom required will be less, and accordingly the kinematic part and the dynamic part will be written automatically. I'm not bringing that part here how we are doing it, but this is again to show you the importance of design for the cluttered environments. So from all these things, what we get is a challenging jobs for design algorithms. And here you will find that how you would like to connect that even the complicated inverse kinematics or motion planning, everything is related to robotics research. But more importantly, the introduction of our today's topic, which we are discussing as modularity. So that is connected to, you give me a new design, but it is connected to the development, right? So here, if anybody would like to ask me, because you can see that if I'm talking about any environment and any robotic this configuration may come out as the result. You will see that this is my, a designer can always say, I have designed this new DH parameters, 6 degrees, alpha is this, D is this, theta is this, and the robot will reach. Yeah, nice, but then this is a design and no manufacturing unit will help us in making a very novel design of yours. Sorry, and this is where the customized design ends normally, because it may be okay, you can do hard thing for making the prototype of it, but in general their future or their application in the realistic world will not be there. So this is where I would say the importance of library being developed in hard form, I mean not the simulation, and which will corresponding to what is being designed, you should be able to make those, I mean, use those modules which is there present in the library, and uh, actually make the prototype ready. So this is all the concept, and this is where I would say that particularly you can break. Now, modularity doesn't mean the entire module can be developed once. You can talk about the library has different parts. You can actually further connect, break it. So these are just to show you that how and what parts will be the individual parts considered, the components of that library. That depends upon, again, the requirement and the flexibility which we would like to incorporate, because we also understand that there is a trade-off here, that the more flexibility, right, may hinder the rigidness, or the it may not be that focus or stiff as required in the industry arm. So we are not saying for very heavy duty you may need it. There is a trade-off here, and so this was just to give you a few concepts, particularly related to the introduction part of the requirement part of robotic arms, that why modularity is being used. So before going further, I would like to take some questions, because as I said that it's not that I've gone a little faster. So before going some another part of it, may I say that how did you find it, and if it is connected to you or not? So because I have a lot of time, so I can always ask my audience if they would like to ask if it is going okay. Yeah. Shall we ask for some questions? Am I audible? Yeah, Dr. Ashwin, and would you like, first of all, may I know if I'm audible, because or I'm just speaking because I'm sitting in a room and I don't know.
Yes, ma'am, you're audible.
Okay, all right. So, okay, so that means at least I can go further if there is no question. But you can relate it to your work. Like it's not that the question from this work, but you can also talk about that what particularly what are you doing, and would you like to connect it to that? So only then this version of mine will be useful, because I'm not giving any details how we have done it, but what you have covered in the last 3 days, maybe that will be utilized here, right? And as I said, now it is important because possibility, and if we are talking about possibility, then many questions come. And this is what I would like to present otherwise. But if there is an interaction required, anybody who's getting any question in mind.
Participants, do you have any questions?
Yeah. I don't know if they have written anything, otherwise I can move forward.
There's nothing in the chat box here, ma'am.
Yet. Okay.
Uh,
Okay.
there's nothing in the chat box on YouTube as well. So,
Okay, this is being in YouTube live. Okay,
yes, ma'am.
so basically, yeah, then we can move further, and
Yes.
they can actually ask after the lecture, right? We can keep more time there. So
Okay, ma'am.
basically, till now, the three aspects which we have covered, and the first aspect is related to our introduction of robotic arms, where we mentioned that this is all related to the serial mechanisms, where the joints are being added, where I mean a particular mechanism for which we are talking about the modularity today. However, it is not confined to that. The same area can be extended. So I'm just talking so that if somebody is liking the area or working in something similar, then they can extend it to hybrid structures, parallel manipulators, and whatever type of structures, even for the applications perspective. And second aspect is was related to, as I said, that even if it is for serial, then modularity. And modularity, the importance is being shown to you. We said, and the third part we had seen that let us do it. The requirement for introducing the customization in robotic arms, that requirement is being shared with you, and that particular part, now it says that the requirement is there, but how can we do it, the possibility, the importance, because even if we agree, I assume this is what I was expecting from you, that you may say that this is not done, or this is not possible, or there's some kind of other doubts which come into mind. But particularly what are the main questions that we see that even if we have set the importance, we have set the requirement, but is it really possible? And what does that meaning of the possibility means? So here I'll go further and now show you that this is all about what is the design. If we say that we need to edit a design, and I am talking about reconfigurability. Right. So reconfiguration or editing a design due to any constraint change or any job change, this is required, we have understood. But first, before looking at or while looking at its issues, like what is the possibility, we'll see that what is being required. So this is just the diagram similar to how you understand the DH conventions. So these are any parameters. It's not that only DH conventions required to be used, but yes, they were normally being used. So these particular modules are planned based upon the DH parameters, and that is your robotic parameters being used this. That means tomorrow, if you give me a table of a set of DH parameters, we should be able to give you the modules which should be able to get, I mean, where we are able to get those particular that particular manipulator get ready for which you are giving me the DH parameters. Of course, with that we need the inertial properties too, right? So if you give me the properties, we should be able to give you the corresponding or associated modules. But what does that mean? So here, in these DH parameters, they define the connectivity and the definition or the definition of each rigid link with respect to each other, the moving body with respect to each other. May it be your A, the link length, alpha. I'm defining, although these are from similar to your the books you are following, but just for the completeness, alpha we are taking as the twist angle, and these are Z1, Z2, and Z3, like three axes being shown. This is a very general way how we represent the DH conventions. And for any robot, and then of course you have to look for another analysis, as I said, some of the inertial properties too. So if we just show you that given any robotic arm may not be the conventional one, may it be like, here being shown is say 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 degrees of freedom, this particular robotic arm being shown at the right side, right? That of course the kinematics of it will be defined through these DH conventions. And now, as I said, the design editing, if I want to change its configuration, then what are the few things comes to our mind? First is, as I said, we can reduce the degrees. You will say, okay, to work for the same task, I would like, we need 8, and for to work in a different task, we would like to, the design which is the output of the design strategy. Say I had a design strategy that according to the points where I would like to reach, the number of degrees of freedom which are required are say 6, and the 6 are sufficient. And with those 6 degrees of freedom, with these particular dimensions, we will be able to work in this particular task, right? Say this is your output, and in another case your output is 3 degrees of freedom. So that means you have a DH parameter in your hand, which is according to the degrees of freedom, and now you want to connect the same modules, right? This is just a concept, and that is called as the re-editing. But writing of the kinematic model, as I said, and is one issue which you'll say, okay, because I know the lengths and I know the distances of the modules being used, then you can, at the back, those config that particular values, so you can always work on the forward kinematics. But there are another issues also, we are coming to that. So this is just to close this particular part of DH parameters. That means we have these 4 parameters in our hands, right, which can be edited.
Hello, ma'am. Sorry to
Yes.
disturb you.
Yeah.
Your screen is not visible.
Now it is not visible, and I'm speaking. Okay. Is it for the last 5-10 minutes? I mean, when we started again?
Uh, last 5 minutes.
Oh, I'm sorry. Okay, let us check it again. You can tell me what you can see at the screen, or shall I share it again?
Ma'am, it would be better if you share it again.
Yeah, I would say like that. I think it has stopped sharing, or this is the reason.
Yes, ma'am.
Yeah. Is it coming?
Yes, ma'am.
Yes,
It's
ma'am, it
coming.
is visible.
It's visible. Okay. So I just go back with one or two slides. It's good that I spoke almost, yeah, this DH parameters. Okay. So we were here, and what I talked about is what we talked about is the same, and which you have understood that particularly for changing the configurations, it is important to see what will be the is it really possible or not, because we talked about many things. We talked about the requirement that wow, it will be so nice to have a new configuration, but will it really be possible? And to talk about that, we showed you this particular design editing, and here you will see that in particular to make any robotic arm, for example here at the right side, as I was talking about these 8 degrees of freedom, right? So these 8 degrees of freedom, a robotic arm, we just made it, and it's easy to simulate, at least till simulation. And we assume that the some similar or corresponding library is already developed, right? And out of that library, many people are working these days, even for modules people have started working, but the idea is how you have designed the modules. So the possibility means first is kinematics. First is the kinematic part of it. That means if I can give the modules which can get set, which can get connected to each other, right? To give the DH parameters, now I'm consigned to the DH parameters only. And of course, you can develop, as I said, for other parameters also, right? But these are generally being used, so we can talk about this. And if we see the DH parameters, then the DH parameters are these four, right? And in this, say, even if it is your alpha as being marked, and A, which are link lengths, twist angle, they are talking about how any specific axis is being associated to the next axis. That is the consecutive axis for the two joints, how they are connected. What is the definition of one with respect to another? Or right. So for that, you use the distance between the two as well as the direction, oh sorry, angle between the two with respect to x-axis. So there is a specific convention which helps us to define the two axes. Similarly, your joint, this offset as well as the joint angle. This helps where the axis, like the direction of x, the x part of the frame, x directions, xi minus 1 and xi, how they are associated or defined with respect to each other. So these four parameters helps us to define a complete link with its joint to be defined with respect to the next link or the prior link prior to it. So if I can create the modules, say this picture is not for the modules. This picture is very common where people do learn DH parameters. You might have already done recently, right? Or even long back. But if I say this is my module, although this is not so nice because it cannot change, it looks like very stiff and rigid. And if I today I say that, you know, whatever is this alpha, the angle is being shown here, and I arrow option. Okay. Okay, so basically that if alpha I want to change, right, that is the angle between the two z's, then only with this rigid link I cannot. I have to make this to be, to be flexible in such a way that. So if you use flexibility, then further issues will come. That means some components should be of such size, such ways which can be connected so that whichever a alpha or theta, or theta is anyway the rotation, we are not talking about theta, but particularly the link parameters, there you would like that they can be changed. So this is about kinematics. The idea is, the research question becomes that can I develop such module, one module, which can connect to the next module with the given DH parameters. Right. So this is what we had solved kind of half a decade back with my first PhD student, where we gave the concept, and nowadays we are developing the the modules. So here I'm not getting into the details of it, but that part I can always give you. I have not marked it here the papers, but we have got a couple of ASMEs in that, and that can be read. But this is all just connecting to you today in this short period about the research questions, that how you can say that even if it is a requirement, but will it be really possible to give the modules? And then, for example, we have worked on the alpha module more, but we have not yet said that, I can give me a offset of say 10 mm, and I'll be able to give you the modules of 10 mm. We can make it, but do we need that reality, that flexibility is the another question, because so much flexibility is also a problem, as I said. And these all things comes into picture when you start working on the static and the kinetics of the system, because the static force or the dynamic force balancing, everything gets changed the moment you make a slight change in the dimension, right, or the complete of the formation. So how to handle it? There you will say that flexibility should be minimum, and we found that only by playing with alpha we get enough of such modules. And some another works just for the key points on, or some other ideas about the modular manipulators. I'll show you that if we are talking about the conventional and the reconfigurable, now by looking at some, at least from the kinematics part of it, if you say that reconfiguration, why, for example, this is again the relation with the requirement, the why we are talking about this reconfigurability, because with respect to conventional, where you have some specific configuration fixed for you, and the second in which you can change the configuration, right, according to the DH parameters. Then the first thing what you get is that yes, reconfiguration is possible here, and in conventions you have to change the complete robot, right? It's a fixed configuration, so it's not possible there. I'm talking from the perspective like it's why it is trade-offs. It's not that okay, we should switch to the reconfigurable. No, you cannot, right? Overall mass, normally, unless you get into details or further research of your maybe materials, right, or on actuators to make them lighter, right? Because if the lighter actuators are being made, that means even conventional robot can be lighter in weight. But overall mass normally for the reconfigurable will be larger. But yes, you can, because if you're comparing the two types with the same requirement and the same technology, because if I say that the technology is improving in materials, we can make the reconfigurable modules lighter, then the same modules or the same technology will be used in the conventional too, right? Similarly, if you say that okay, we have better actuators coming very light, then in both you will compare them in conventional as well as in reconfigurable together, right? So in totality, by using the same technology in both, the overall mass of reconfigurable will be larger because the components are more, and you are not creating the reconfigurable only to become the configuration which is being shown in the conventional. Because if conventional you have some 6 degrees of freedom, okay, but in reconfigurable modules should be such which should be able to do extra things. And for that, your modules will have the capacity of doing little more as well as little less than the conventional. And that is why their components will be little heavier. Normally, their overall mass will be more. Dynamic performance is comparatively lower in reconfigurable because, in conventional, when everything is fixed, the mass is fixed, you can always work with the better dynamic performance and accuracy. But because of introduction of flexibility and not less rigidity in reconfigurable, the dynamic performance is normally, I would say, affected. And this is how why I'm showing this group all these things rather than only the my work and pictures, because you said that you are working with the, you would like to know the robotics research areas. So if you are into dynamic performance and you are working in such directions, you can always look at the recent works required, right, in the modules which may have better dynamic performance. Mean time to repair, certainly in reconfigurable it is better, that will be lower. And this is how it is connected to industry 4, because we have to now this part of the work this second portion, as I said, that after 11.5, I will be moving towards your connect it with the industry 4. So here you will find that mean time to repair is lesser. This is the positive part of reconfigurability, right? So there, conventional, it's very high, because if something is going bad, then okay, it's not that robots get needs to be worked upon very soon or frequently. No, even the conventional manipulators, they are good enough, robust enough to take up many of the issues. But still, if there is a comparatively, as I said, comparatively, the problems related to the minimum time period required for repairs or downtime is certainly lesser with reconfigurable. You can give better answers because the entire model library is with you, and the controller is adaptable, the dynamic model, everything is, you have been always being ready with the new modules being added, or the module, or the faulty modules to be removed, right? And how to reconfigure it, how to reprogram it, that is faster in case of reconfigurability. Availability certainly will be far higher, for which we have actually designed the reconfigurable. And similarly, the initial cost, but I'm not saying the cost is high. Initial cost normally in configurability, in customization is anyway high. So if you are looking for customized robots, then certainly your cost will be high. And in case of reconfigurable manipulators, your initial cost is higher. And now you can work with that. Yes, we are looking for further questions in research, where by using, say, any advanced technology, you are looking for the reconfigurable modules, which should be lesser in cost. Customization should be cost less, right? So as I said, now we are coming to, this is a 2020, but just a decade back, how people have worked, that a drawback of the modular approach is the lower mechanical performance. And if this is recent, so many people in the last 1 decade, they have worked on the dynamic performance. My work recent, the second part of my this PhD, current PhD, as I said, is particularly on the dynamic performance, right? And there, my another work is also on the reconfiguration, where I'm not talking about only the serial arms, but how to give the reconfigurability actually in serial as well as in parallel, or their hybrid together. But that is just at the very initial stage. We don't need it much, na. This is the reason. As I said, our need should be there. Whatever I've spoken, I'll just take a small case study to show you what does that all mean. The terms which we have used, the takeaway for today, the terms. So the first term is like customized robots, and we have talked about, okay, the customization, the task-based robot, the task-based requirements, right? And then design, which is related to the tasks, right? And then if we are talking about how the modules will be developed, that is right. And then how the reconfigurability will help in any particular case, that for the same environment, you need a different configuration sometimes. Why? So to show you, this is a small case study which you can show. This is again for in my group also. Now it's 4 years we worked on this case study, and I'm just presenting even in the time scale, so that you can connect to whatever whichever way it will be helpful to you. So here, for example, this is actually a vertical raw mill, and there was a problem of there was a crack. And the idea is, because this was given by some of the student intern working with me, and he said that he was very fascinated by the modular idea. So he was discussing it wherever he was going, and he discussed with one of his I think his father himself, who was working with the welding firms. And they felt that, do you think that in the welding of these cracks, which are at the very intricate locations, will such module or any library can be developed? So from there, we got this idea that, okay, let us show this case study. And we say that this is very large, and you can see that this is some location in which there is a crack. So what we did is, at that time we were not working, or we didn't have the algorithms which could take the pictures directly and can develop the the environment. So we actually ask them to send us as much possible the dimensions of that particular only, not the entire machine, sorry, location, but only for the particular section of it. So from that we just developed this. This looks very small, but this is just the idea that okay, whatever part in a different goal orientation is being shown, that we had developed that particular part, and we know that the sizes are very large, and this particular environment was developed. Now what is required next is, so first is the environment, right? And second is the locations. So in that environment, we wanted that some of the task-based locations are marked, right? So I'm just showing you the glimpse of the work. And if they are marked, now the idea is that we are looking for a robotic arm, which may have, because when we are designing, we say that the base location can be fixed and the base location can be kept as a part of the design, or it is a design variable. So if I go back and look at this case itself, the situation, then in the beginning, you may decide that, I would like to keep the base of the robot to be fixed somewhere here, just below wherever the crack is there, somewhere here. Until there, we can have a kind of hydraulic lift, any pneumatic lift, which can help the robot to reach there. I'm sure even the manpower who would like to work here, right? It was so high that wherever it stands, and then to get their welding things get settled there, this was not get, because I said it's not that we had identified the issue. The problem was identified by the welding firm themselves, that they get the labor, but sometimes to get the thing settled there 2 days of the labor goes, and then only they get into such intricate locations, the crack. But point is, if we have a library ready, and you can always get it adjusted in some of the hydraulic lift, as I'll be just showing it, and then the manipulator part of it can help in working in any of such directions. So only thing is, the customized manipulator needs to be developed according to the given task. And there were two tasks there, the crack at two locations. So at one of the locations, so these are the DH parameters. For example, we get these DH parameters, that to work here, can you see that these are the black lines being shown, right? I'm just zooming that, because it was a very heavy, sorry, very large profile of that particular location, right? So in front of them, the robot which is which is being designed, this from the base is already at the height, and there were some red marks which were showing the the locations where the robot needs to work, and what should be the DH parameters which should be helpful, they are being shown here. So you will see that some alpha, A and D are coming. Now who will understand it, right? So your simulation will have no meaning if you cannot give an example, or cannot give the idea of the development of that particular robot. And there comes so this is just again the simulation to show that whatever were the resulting robotic arms, one was I think 8 or another is 7 or 6 degrees of freedom at the two locations. So it is being shown in the same picture, but actually they were a little apart. One was at the front side and one was at the back side. So when you are working at the front side, then the requirement according to the complexity was different, and when we are working at the back side, where there was some further constraints, if you can just notice, there were further constraints in that, and because of further constraints, you need extra degree of freedom, and that is why at one you have one configuration, and at the other side you have another configuration, and they can connect it. I'm not saying that today the technology is that developed that quickly it will be connected, but once the importance is being ready, and with the better research, now we have already developed the such modules which can be connected. And here you will see that the modules are different colored also, because we have developed three sizes of the modules after good background research and it's I'll not say research, the word is analysis here. We had seen how many sizes will be enough. So our work is not homogeneous or heterogeneous in nature. In fact, it is hybrid, and we are working with a combination of the two. We say that the modules are not the same size, because the how to get into that these blue sized, they are designed in such way that every module of our has a particular feature, as a particular specification feature, and that is how many similar modules it can carry, right? So if we are working with three sizes, heavy, medium, and light, so you should say that if these blue are the medium size, so how many medium sized modules will be carried by it itself? And then of course it will not be asked to carry any heavy duty or heavy module, but it will be able to see how many minimum of its own size, as well as, so you need to do all this probability, not really probability here, but all this actual analysis where you have to give the exact number, maximum number, which should be carried by a heavy module, and and after that enough of analysis that once you are asking it to be connected, then you have to look for at least from the static performance, static balancing. So I'm not getting into the details of it. This was just to show you that how we are working, and I have not shown you the results from the dynamic performance because that is in process. Only 2 papers are out yet from the dynamic performance, but still I would say that that part is not being added here, but it's an open problem. If you would like to also work in the dynamic performance, then you can read about it, right? Those papers are already there at these normal open forums, and you can always check what is the importance of dynamics here. You can see the importance rather that how different groups are working in performing better, in first of all to decide that what should be the size, and then to minimize the mass of the robot but still maintaining the dynamic performance in a good shape. So this is about the introduction of the modular robots. But now a little part I would like to cover from its connectivity, because whatever I spoken, all these I said that all those terms are the takeaways for today. But this how it is connected to industry 4, because as I said, robotic arms to begin with were actually they were associated to industry 3.0, but now with this new era coming, already, I mean, not coming, but already we are into it. And what is the meaning of modularity? And there you will see that to show you that particular connectivity of robotic arms or modular robotics with the industry 4, I had taken these pictures. Actually, this is the from the web pages of Samarth Udyog Bharat 4.0, the platform created by the department, the Ministry of Heavy Duties, Heavy Industry, right? And there the importance is there, and enough of data is also there. I've taken some part of the data directly because this is authentic. This is authentic, and if I connect with the authentic, right, then you may like it better, and that means it will be journal in nature. So whenever we are talking about cyber, but with that we have associated the cyber physical systems. So it's not that the current research is only in the algorithms. Mainly in industry, what you need is okay, the adaptable algorithms to connect the processes or their inputs and outputs, right, with respect, and first to controllers as well as everything from a distance. You need to connect it to the clouds. That is cyber system. But then the physical system itself, as it is, what it is presently there, right, that cannot be connected directly with the cyber cell, with the clouding, right? You need to make some changes in the physical system also. And this is where you will find that linking the cyber and physical, incorporating AI, and enabling the customization and flexibility, everything needs to work together. And there comes the importance of this customization, because there also if you'll say yes, quickly it is being ordered or it is being noticed, right, that a new configuration is required for 3 days or 4 days according to a new product to incorporate the flexibility, then maybe by utilizing the minimum manpower or as decided, or without utilizing the manpower, the robotic arm, the design can be developed by taking, as I said, the new environment pictures. They may come, and according to the new model, the robot will be developed. And of course, some manpower will be required. As I said, these modules are not self-reconfigurable. Now I can use those terms which we have introduced to you today, because it's not self-reconfigurable. Still, it can be reconfigured by having some minimum manpower, and then that can be used for the new flexible work. So this is all what I have said. that Industry 4, the requirement today, which is upcoming, is additive manufacturing, 3D printers, and collaborative robots. So, collaborative robots are important from the perspective of the controller, from the perspective of their intelligence, and of course, from the perspective of their reconfigurability too. Right. So this is just to connect to the next century, and particularly why we were using, why the importance of Industry 4, that I'm sure that you have studied, you have seen separately, right? But we know that even in the last few months itself, with the new schemes coming, new platforms, plethora of platforms coming from the government itself, for getting, which is getting, as I've written, the manufacturing sector is getting the major attention. So we can always connect our understanding, our small research to the requirement, so that we can actually contribute even to the Indian robotics, which needs to be connected to Industry 4. We already, I would say, there was an era Industry 3.0, but we were not. I can say this, that we were not to the level already adapted 3.0. Right. So now it's not important that first we'll finish that and that. No, not like that. But wherever required, the available infrastructure of robotic arms needs to be changed, or so that they can be a part of the big system, cyber physical in nature. Right. So why we were using, because without this cyber, these are the important which is being written at the lower side. They are for the more production than actual, because even if there were checks, but sometimes the production is little higher, or what happens is the information being received was slower, and by the time any inefficiency was not getting noticed, and for all these things, we used to have the extra manpowers to analyze the things, what has happened, why there is a deficiency, right? So all that is minimized with the cyber system, where everything is connected and you have the information and you have the complete database, or you what you call as the data handling. But uh, with all this is all about information. This is all about the information at the right time, better in the better form, in the required form, and some information which were not even thought about earlier, and controlling from a distance. So cyber is all about that, majorly, I would say. But while doing so, what is the decision to be taken? Decision is still to be taken, right? May it be automatically, may it be for a person who is analyzing it from a distance, right, using the cyber things. But that decision is still related to what is to be, if there any change to be made, as I said, to minimize the repair time, or if you have seen that any repair is required, can you look for modular links which can quickly help itself, and or by minimum manpower, which can be helpful. So even with the correct information or informed information, we need to work with its decision, right? So these decisions are related to the physical system of it, which has to be in corporation or in correspondence with the cyber thing of it. So focus was always on the changeover improvements on the machine. So this all data I've taken, all pics I've taken from the authentic grounds of these websites, so that we can connect that whatever is required in the market there, how the importance of reconfigurability is coming, because changeover improvements on the machines is extremely important. This is one of the focuses. And if required, like, not only that machine is not working well, it is all that because of the change of the product, to introduce better flexibility, you may need something to be developed only for 3 days, and then you have to change the setup a little bit. Then what will be required is, as I said, only the customized systems, right? So just quickly showing you further requirements in Industry 4. This is all what, when we are discussing on Industry 4, we find that these are the aspects. And location detection, okay, this will be done by the cyber system. And then what is being required is that I'm not showing about this augmented variables. I'm working in that. That is why I've marked it. But advanced human-machine interfaces are required. So this is related to the safety of the human beings being connected to the robots or any another machine, right? These interfaces are being required. So I'm just highlighting whatever is required from the robotics perspective in the research fields associated to Industry 4. So with this, almost my discussion regarding the 2 points, and that is customization and Industry 4, and how the modular robots are playing its role is almost over. But I would like to, because as I said, this is whatever is being written at the lower side is just the crux of the things, that for the better utilization of our equipment, it's better that it's not that you have a robot today here and then you'll say, okay, cooperative robots in its fixed range, we call them as cobots, which are being developed by many firms these days, small in size, large in size. Yeah, but then you as industry would like that, can we develop? Now I'm talking to the final question, research question. Can we develop a robotic system, as I said, a modular library, which should be able to give us the smaller or the larger? May not The same library may not serve the purpose of all the applications. This is what I'm now coming. It may not come and serve all the applications, but at least to a set of applications. So this is what our vision is, to answer this question, that can we develop at least a set of one library for a set of problems, and then you can develop the robot according to the requirement and then reconfigure it if the requirement is being changed. Right. So this is an era of tailor-made products, the customization, more utility, variety of applications. Right. So this is how I would like to show this particular picture, where whatever I was talking, this is our vision. And I would like to show this is the vision as I've written from the Modular and Intelligent Robotics Lab at IIT Roper. And to design of the modular library, where we say that the environments will be changed. If it is assembly shop, it's very large. Manufacturing, maintenance, repair is very small, and services. We are mainly working for the maintenance, repair, and services. And if this is actually the very deep study we have done, that how different applications, which we started with in the beginning of the chapter, how these different applications can be clubbed together according to the size of the robotic manipulator which is being used there. Not only just size, I mean. Normally with size, your information about degrees of freedom as well as the information about its carrying capacity, everything is there. So I can always say on a major scale, size, right? So and according to the requirements, because if it is only for cleaning, you have one set. If it is for welding, you have another set. You can have a modular system or a library only for the welding things, because welding, you need you need interaction with the environment, but in cleaning, the interaction is different. In serving, the interaction is normally not there, right? In pick and place, you have different types of requirements. So it's not that the same library will really serve everything, but you can actually develop on these strategies so that the different libraries can be developed. So with this, I think my information regarding the modular libraries or modular robots on Industrial 4 is over. And now I show this video, which I told you that it is almost whatever I spoke. And in just a few, 2 minutes, you can see this, because this is just from our recent works using the robot operating system, that is a ROS environment. And yes, this is I'm sure you know it, but all of you, please train yourself, your students on ROS. We are also learning, we are arranging different workshops for ROS, and that is required for the global working. You will see that H is for heavy duty, L is for the lighter, and how we are developing at the DH parameters first, and then adjusting the twist angles accordingly. Then the modular sequence is being designed, right? So this is all being shown here. So this is actually heavy H1, H4. These are all names being given in the robotic system itself. And this is actually our 1 or 2, 3 years back work. I mean, not 3 years back, but 3 years work actually in our modular robotic systems, particularly using ROS. And this was just a short video for the recent times, and to give you the just the idea and the closing of this particular lecture. So with this, my discussions on the given topic is over. And I also just tell you, because in the beginning, Ashwin has introduced about my this platform called Punch Robotics, and I always talk about it. For to know a little more about it, you can check the webpage as mentioned. It's simply punchrobotics.com, and you will find that we are trying, because as I said, for the upliftment of robotics, at least in your institute and around, or whichever contribution way you feel is correct, that you should try. And in that direction, this is our contribution, where we feel that more interactions and more discussions at least help to improve our work. And this is all the background, and somebody wants to connect to us, they can write to the contact being written at thepunchrobotix.com. So with this, I close. Thank you very much, and I stop sharing.
Thank you, ma'am.
Thank you very much.
If I may ask the attendees, do you have any questions you can ask now? Participants?
Yeah. I hope if this was useful or whichever it is.
Yes, ma'am, it was very useful. I don't think there are any questions from the attendees. I'm just checking on a YouTube as well.
Okay. So no, that is not an issue. And in case there is any, they always need, as I said, they can connect to us. And but this is all because I actually checked the title. I didn't know exactly the entire plan of your course, but I
Okay.
checked that the title was related to this
Yes, ma'am.
robotic research. Yeah. So
Yes,
I
ma'am.
thought of at least telling some of the directions which are related, and if somebody uh, gets motivated for any of the directions. So this is how I planned, and I'm sure that I hope that this was for any use by the, or maybe later they can find it, they can read it,
Yes.
and if somebody wants to connect, they can always write to us.
Yes, ma'am. I'll surely tell all the contestants if they are all the attendees if they have any questions. We'll surely mail them to you, and maybe we'll ask
Yeah,
them
yeah,
to
sure.
connect. Okay.
Right, right. So with this, because the interaction is short, so I think we go faster, or we don't know because the feedback was not there, but it's okay.
Yes.
And from my side, it's over. So maybe I can then leave. And if there is any question later, I can just check at the chat.
Yes.
There is nothing. So you
Yes.
can let me know. Yeah. Okay.
Yes,
Thank you
ma'am.
very
Sure.
much.
On behalf of Mechanical Department of Bharati Vidyapeeth College of Engineering, I would like to thank you for giving this wonderful session today. This session was really actually very helpful, and I'm sure that many of our attendees and even this college will try to connect to you via your punchrobotix.com, and
Mhm.
maybe we can take it from there. Thank you,
Yes.
ma'am. Thanks once
Thank you.
again for this interactive
Okay.
session. Thank you.
Thank you. Bye.
Bye. Uh, Contestant, attendees, participants, your next session is going to begin at 12:30. Your next session will begin at 12:30. The link will be the same. This is the same link on which the next session will begin. We'll see you at 12:30. Okay. Thank you.